So it is being recorded.
Okay. And I have some to you, Dmitry. If you will speak for me, please remember that if you speak not so quickly, I will understand you more quickly.
Okay. Okay. I'll try to slow down.
Thank you.
Yes.
Thank you.
It's time to begin. So it is my pleasure to introduce Revolt. Well, for me, he's Volker. For a simple reason, we started in the same school at the same time, famous 45 school in St. Petersburg. So I know him for ages. And the title, you see that on the screen. This is going to be a rather unusual lecture, but I'm glad to see him speaking for us. Thank you so much. Please begin.
Thank you, Dmitry. I'm sorry for my bad English, but I hope that language of geometry and language of art will help and understand one another. And I will speak about geometry of circle and about some understanding this geometry that I named aesthetic geometry. Aesthetic geometry, I mean, is not only some method drawing something nice, but I named so unified method understanding inversion, maybe a new method, and it is very strange, but it is fact that with help of this method we can do many nice, beautiful, harmony aesthetic objects. And the first of these objects is here. In the first part, I speak about some laws of these objects and show video art. And in the second part, I will speak about understanding geometry, understanding inversion, maybe new understanding inversion as symmetry. I will speak about some non-good place in classic definitions inversion, and I will speak about another definition understanding inversion. And here we have the bird of peace, and it was making in Coral Draw with help composition about 4 circles. And I show next cadre. And here we see in the right, we see the spiral, Barak spiral, that shows this composition more clear, composition inversion about 4 circles. It was making in Coral Draw and with some macros for Coral Draw, and one circle was moving about this composition, and after this I used the function if point is under even circles, they don't show. If the point is under odd circles, this point are shown. It is, as I remember, a function of Möbius, and it is very interesting that we have some pictures. And the first picture was part of such spirals. And this is, in the left, we see as I name it, Cheburashka, the personage Russian films, and cartoons, and it was result play with such spirals. It is very surprising that some easy play with such spirals are very interesting and lead us to zoomorphic or anthropomorphic forms. I will speak about in the next parts. And look on these spirals. If we are math, and it is clear understanding that we see two centers of these spirals, and we can say that first center is 0, and second center is infinite. And after this, we can understand this spiral as logarithmical spiral after some conjuring quotient linear transformation. Or we can understand this with help of stereographic projection. But if we do this clear step in math, we lose some visual properties of visual variety figures that we have in such spirals. And after this, I will show to you this variety in a it is now I show variety forms of aesthetic geometry, and some comments will be. This here we are near one of centers, such spirals, and
Volker, I'm sorry. I understand that you are not at an American university, of course. You use the word spiral a lot. It's pronounced more like spirals than spiral.
Spirals.
Yeah,
spirals. It is better.
I'm sorry for that, but
thank you. It is my second try speak in English in such. We saw, and if we want to research some regions of this picture, I think we must use number theory, but it's another, it is not short. And this is very interesting that we can, here that is result one spiral, but in some regions it is ornament. We can, it is very strange, so variety we can see. This is, we can, if this, as I say, we can name one center 0 and another center infinite. And we can connect with some spiral complex number by this result. And if this complex number is the square of 1, we can see some symmetries. Now it is 5 symmetry. It is some play. It is some play of such spirals, and this is near one of the centers of these spirals. Some flowers, another flowers, and it is not flower. From this disk we can see very many illusions if we move this disk. When I look in Corel Draw, it was very interesting. And this is, I think about works of Russian painter Pimenov. I remember that in his works we have many triangles and straight lines, and in down we here so, but it is essential. It is not straight lines.
I apologize. Sorry, there is a message in the chat which may be very relevant, which says, "I didn't get the general procedure for those constructions. Can you explain again?"
Thank you.
There is a message in the chat. You can see.
It is a result of easy procedure in Corel Draw. I take 4 circles and do composition inversion about these 4 circles. And this composition work with another circle, and this another circle with all traces do some way, some move, and with all traces. And these traces I use for final picture. I used function of Möbius. If we have one circle, and if the point lies on the even circles, it point don't draw. If the point lies on the odd circles, this point is draw. And this is very easy procedure. I do this in Corel Draw with some macroses for geometry of circle, and all varieties of figure was with these spirals will do so. And this is we see transformation of it is really circles in all parts of drawing, but for our visual, for in our eyes we see circles here, and in the down we see straight lines because the radius of these circles are very big. And for me, it is remember work some Russian painter Pimenov. And this is play with spirals. It is very strange that some easy play with spirals. Here in this picture we have 2 spirals, and one reflect 2 spirals, and after more than these spirals, 2 spirals, we can see very strange figures that are beautiful and interesting and artifact. And what I want to say, if we work as math, we can understand the spirals as logarithmical spirals, but do so we lose all this play, all very many visual properties will lose if we think about these spirals as logarithmical spirals. It is very important that we see in really 2 centers, and no one of these centers is infinity. This is another example of this play. Okay. I don't know why so often we have anthropomorphic figures as a result of this play with 2 spirals. This is forms, maybe
anthropomorphic figures because you are human.
What? Sorry.
You interpret anthropomorphical figures because you are human and you are used to seeing human faces, I guess.
Sorry, I cannot understand. Maybe after I can understand. And this is picture.
I'm sorry, I didn't understand either just because I was typing an answer in a chat. Can you say it again?
It wasn't very important. I was just saying that we see anthropomorphical figures because we are human and we interpret those figures as human faces because we are used to seeing.
For me, this sounds like a very nice guess, but I can't say for sure. Okay, sorry for the interruption.
It is also play, but for me, it is one picture. It is music on the air. I see this pupitres, notes, orchestra in the air. And this is another play, The Mask of Absurd. And this is same procedure in 3D in stereometry. We can do so, we can work with symmetries about, with composition inversion about for a sphere, and it is very many nice figures and with very many variety. And we have some interesting connect with topological swatches of this for spheres and properties of such figures. And I say now I say one such properties. All spheres will have intersect one another. Three spheres intersects in 2 points. It is easy. And for properties of such figures, it is very important. Fourth sphere divide points of intersection first 3 or non-divide. If for fourth sphere non-divided points of intersect 3 first spheres, then in such the result of work we will have limit points. In common case, 2 limit points, sometimes 1. Another points will in infinity. And if the fourth sphere don't divide points of intersects in other 3 spheres, we will have knots, very interesting knots, and we don't have limit points. We can work our four sphere can move another sphere and can move tetrahedron or another figure, and with the aesthetic point it is very interesting change sphere, moving sphere on moving tetrahedron, and we have it is very strange, but it's true. In all cases, we have something nice. And this is knots, as I say earlier. We can rule properties of these knots. This is one line, as must be in a knot. And now in this knot, we have 10 vertex, maybe 10 symmetry. And this is not knot, it is very interesting surface. And this is another cycle. This is earlier I show work with spirals and work in 3D spaces. By one more composition inversion about 4 circles or spheres, but now I show freeze frame of video art. It is I show video art, but now some freeze frame. It is Незнакомка or strangers octopussy. It is named so, stranger octopussy. This is without name.
Revolt, I'm looking at the chart, and probably it would be helpful, if I understand the question from Chris Lloyd correctly, if you show some of them in dynamics. That would tell more.
One moment, it is 1-2 minutes, because I cannot show in dynamic all, or I show in dynamic only some examples. It is the morning, if I speak in English good. And notes, we can do notes in this regard as well as pictures. The end. And now I will show video art in dynamics. I have special program, Colloquium, for demonstration this video art. Out of program. 1 moment. I have very many examples of pictures, video art, and so on. Yeah. We start with Cosmos. It is without repeating, without end, without limits, limit points. We can do some changes in this art. We can change colors and some other changes. I will speak about this later. Now I will only show as for pictures. And this is interesting that I hope you see harmony these images, but it's very strange for me that rhythm, the changes of these images are harmonic also. I don't know why this. This is morning. Earlier I show freeze frame, and now it is I show all picture, all work. It is very interesting process creating so images, and as I will speak later, very many interesting math problems connected with such forms. We can say that it is some dynamic systems. I named this dynamic system DDU systems, named by extension of files that contain this work, parameters of this work. Another example. Another style, black and white. It is very interesting playing with black and white. I see here some profiles, some human profiles, but the subjects, it is another example, maybe not so art, but this example is main is for math. What was do? I do some notes, and after this I break this knot, and I do this using commutator. And we have some formulas and using commutator, and after this it work as some surface, and this work very long, and we have free symmetries, free first symmetries all time, but the forms will change, and now we can see that the surface. Another still. Some joke. Now it is more beautiful if we see work not with circles but with squares. It is without end, and it is joke. We can see some figures and some parts of pictures.
So may I make a remark?
Because of course,
because there are plenty of interesting unanswered questions in dynamical systems behind these pictures. What we observe needs justification.
I will.
When there is periodicity, what kind of knots you can see. There are lots of purely mathematical questions which are, I guess, not answered.
I have some words about this, and now I go to my presentation file. One moment. This is, I'm sorry for Russian texts. You can download program with this video art or demonstration this video art in the Google Play. There are English version in Google Play, and you can play a book and think after downloading this program to Android. Do the commutation, do the look. And this is about math. I ended about nice, about video art. Aesthetic geometry, now it is diagram possibilities of aesthetic geometry. It is unified method understanding for some sectional geometry, some parts of geometry, and maybe parts of math, good examples of Fairy groups, and it is very, and today I try to show modeling of non-Euclidean geometry. But after this, I must say about classic definition inversion. Classic definition inversion based on distance, on centers, on straight lines. These concepts are not invariant after inversion. It is not good. It is very interesting. Can we have understanding or definition inversion that don't use non-invariant concepts, non-invariant qualities, and this understanding using only circles for definition inversion existence. And now I show this understanding in the next frame. Oh, sorry. For this, one moment. I using some special program for geometry of circles. We I understand inversion not as not transformation about circle. I think that inversion or another symmetry can understand that with help two pairs of points, and sometimes one pair, but for inversion, two pair points. A is symmetrical C, B is symmetrical D. How we can create point symmetrical some point X if you know this? We can do this very easy. I take point X in the up, pass one circle through A and C, one pair of symmetrical points, and pass another circle from B and D, another pair of symmetrical points. And the second point of intersection of these two circles is a point that's symmetrical upright red point. This white point is symmetrical, this red. In this building, we don't use centers, lines, distance, we used only surface. All that we used is invariant for this, it's invariant about inversion. It is very, very main that we can do so. And I must say that in symmetry about line, we have not some easy building we can do. And after building only two circles, we can do symmetrical points. We haven't so easy procedure in geometry of line. We must know distance, we must have some instruments. This we do so think in another mode. I move white point and symmetrical point move, and we can see unmoved point. Of course, when to solve tangent, we have unmoved point, and all this unmoved point lies in one circle, and this circle is a circle of inversion. It is our transformation is inversion about circle containing these unmoved points. We have the interesting theorems about four points and division of these points on pairs, but I don't speak about this. I speak one moment about it is we must be sure that such definition is correct. We have in this one pair of symmetrical points, another pair of symmetrical points, and we find after this symmetrical for red points. And after this, we have not two pairs of symmetrical points, but three pairs of symmetrical points. And we must be sure that symmetry that defined these two pairs is equal symmetry that defined another two pair. It is non-trivial. But it is so, it is not very hard theorems, and in classical it is bundle theorem. If we read in literature, bundle theorem. But all that I read about bundle theorem was not connected with inversion, and in reality, this theorem grant that our definition of inversion with help two pairs of symmetrical points is true, is correct. And in this picture, we see three intersecting circles. Three intersecting circles, as I named it, three circular, is very important figure in geometry of circle, because three intersecting circles define symmetry or inversion, as well as two pairs of points. It is symmetry when points in pair change this place. This change, and this change. And we, after this, we understand that three circles define symmetries of circles. And now I go to non-Euclidean geometry, as I show how geometry of circles can modulate free geometries or absolute geometry, as we want to say. So I'll close this and I return to file of presentation. If we have three intersecting circles, we have three cases. As I write, intersection points of two circles lie on opposite sides of the third. And I named this three circles Riemann three circle. We have another cases that intersect. In another case, the points of intersection two circles lies on one side, relevantly third. And we have some cases, last cases, when all circles pass from one point. We can think this so that if we can move circle C from first picture, from first figure, and we will go to this situation, we maybe pass from this situation. In one moment, third circles will pass from points of intersection to another. And it is, and this is, and we can see from these three circles as in triangles of free geometry. We can do so. We can pass circles from pair of points of intersection in the first pictures. In all pictures we can do so. And all circles go passing from 2 points of intersection. We can name it as lines of geometry. And and if these circles have intersection in 2 points, we can name it pair of point of intersection as point of geometry, of absolute geometry. And we can, it is easy to understand that in these cases, we will have a geometry of Riemann, because in these cases, all such circles will intersect. In these cases, we will have geometry of Lobachevsky, and this is, of course, geometry of Euclid. And the circles will lines of such geometries, and the symmetry about these lines, of course, will inversion. And angles with lines of geometry, of course, will angles between circles that represent these lines. And we can think about three circles as triangle in this geometry. We can understand altitudes or bisectries or medians, and we will have some some theorems that all we know, and we can some unified method for proving these theorems. It is in the spirit of Bachmann. I must say that Bachmann, in his book Building Geometry on Foundation of Concepts of Mirror, he do this very well, but he don't use circles. He work only with lines. He don't do these models, but he proves these theorems with help of symmetries, and this is with help of circles is very easy. And this is about non-Euclidean geometry. It is good. And now I return to video art, and I will speak some details about laws of video art, and in spirit that Dmitry said earlier. The first what we must understand, and that is important for visual work, that if we work in geometry of circle, it is not different. Circles are big or small. It is a circle, and all circle may be, and all circle are same and equal. But when we look, when we in physics, when we are painting or we are physics, it is very important. Small circle and the center circle and so on. It is another situation, not situation, pure geometry of circle. And the great element of video art is two intersecting circles. By these reasons, I show the composition symmetries about two intersection circles. It is not news, but it is have main. What is in this picture? I took some circles, gray circles, and that gray circles moving by composition inversion about these two circles. And I look as moving center of these gray circles. It is not easy theorem. It is not very. It is easy. It is easy theorem that the center of gray circle will move in by ellipses or hyperbola or another conic sections. It is very easy way defining building conic section. We must look as moving as move center of circle. And where are centers of these ellipses? Centers in this picture we can see two envelopes curves, envelopes circles, and the centers of this enveloping circles is two focus of these ellipses. And if we will think, if we show this in dynamic, we can see that velocity moving this yellow point is in a good connection with Kepler's law. And this is for hyperbole. Another, we have focus hyperbole, and these focuses are in centers and enveloping circles. It is basically element for video art. And now I show some part of laws of video art. I don't know all laws, but some small part of these laws I do, and I know this. One moment. It is all examples of video art. These notes and these ornaments. These ornaments is a knot with very big vertex, very big knot. One moment. Now I open program when I not show but work with and create these images. And this this is one moment. This is same planet systems, and I show mechanism later. Now I say this is a sun. This is a sun, and this is Earth, and this is moon. We can say that we have some hierarchy. Sun have hierarchy 0, Earth have, and another Earth as another planets have hierarchy 1, and green Sputnik, green Moon have hierarchy 2. And how, what is the law of this movement? It is, the law is such on previous figures. One moment, now I try show mechanism. It is these two circles as two circles from previous cadre, and moving the Earth is composition inversion about these two circles. And if we think that really Earth is a center of this circle, that the center will go by ellipses. And all these two circles are orthogonal to this sun, and by this reason, this sun is unmoved. And these small two circles, dark circles, is circles about them moon is moved. These two circles moved by composition inversion by this first, and moon is moving about this and about first this. By this reason, the moon is going near the Earth, and one moment, it is better we see these two circles, and this is circles. It is circles for Earth, and this is circles for Moon. Of course, we can create circles near the Moon, and the Moon will, after this, will have some another Sputnik. The hierarchy of the Sputnik will free. And this idea is common for very many work in video art. This is the idea it is realized by some interactive forms. We have not time to go in such details. But I put now one question. We see that the curves or trajectories not closed. The trajectory not repeat, not going, not closed. And we must ask, we can ask, why so? And can we do that curves are closed? In that case, we will see knots. It is very interesting math. It will be so if the angle between these two circles are equal, or in Russian equation, angles to these two circles. In these cases, we will have a knot, and knots. We will have knots in variety knots, variety hierarchy knots.
I'm sorry for an interruption. The tradition of the seminar is that at this point, it is a Zoom seminar, so people who want to stay can stay longer. At this point, we reserve several minutes for questions and a little break, like 3 minutes.
I'm sorry.
Then we can continue for those who can't stay and who want to stay. Zoom allows us that.
I'm sorry that I better work with time.
So at this point, I suggest that we thank the speaker and hope for maybe some continuation. I would stay for longer. I don't have anything I have to do immediately. But some people have to teach, some people have other seminars, so there is flexibility. Thank you so much. And please, time for questions for this part.
It is great.
I tried to answer some questions by myself. I'm sorry, I understand that you are speaking and you can follow the chat. I was following the chat.
It is great, but where I speak more than half, I speak very many. And but for questions, one moment, I show my questions. I'll show my questions.
What I already typed about the knots, if you use two circles, probably all knots are torical.
I read, Dima, I read your question. But I answer this in our meeting earlier. If you want, of course, you should. Not only rhetorical.
This box blocks the window. A black box.
No. I can say that not only rhetorical knots, more complex knots, rhetorical knots will, if you have only hierarchy 2, if you have hierarchy 3 or more hierarchy, it was more complex knots. It will more complex knots. And I have some it was math question, and I have some.
Here is a question for you in the chat. Please look.
Oh, chat. Okay. Thank you for your question. Of course, here I work on the plane, and definition of knots is not very correct, but we can do analogical work in 3D in space. We have no problem with this. Or we have only one problem. The programming 3D drawing is not so easy as programming on the plane. And we will have in 3D all types of knots, not only theoretical knots.
I think that there are two issues which are very different. I'm trying to answer Chris Lloyd's question too, if I understand it more or less. One of them is that, okay, we're working in 2D, but there are additional dimensions. There is time. We add colors depending on time, which goes over which, so we really see a diagram of a knot. However, the curve doesn't have to close up, but in any dynamical system, if we wait for long enough under reasonable conditions, we see the trajectories almost close up. So we see plenty of asymptotic knots. If you close up the trajectory, when it comes very close back to itself. And we can ask what can happen there if we look at such knots. I'm not sure if my explanation is reasonable.
It is it is question for me or to
maybe for the one who asked the question, whether I could answer it more or less.
the knot is not very good. Maybe it's not excellent word.
But
I can show example that figure is not knots, but the law it's law of knots. One moment, if you have time, 3 minutes, I show this.
As you are looking for that, I would say something about what I was thinking. So you have dynamics in the 3 sphere. Then you can take a trajectory, wait for a long time, it comes close to itself. You close it up. You get some knot in the 3 sphere.
One moment.
And this is some kind of a picture of the dynamics, which kind of knots it produces.
It is a not very simple knot, but the moving objects is very big, and it is we saw the law is law of knot, but visual it is of course not some knot. It is surface and very many other properties, but it's for the systems, it is a knot, some knot. And there are very many problems for analysis, and developers and another analytical moment are very interesting. And dot density, that is another questions, and the laws is very easy in that cases, but the properties not very easy. Why say not? Because it's so low as was sun, earth, and moon. In this, we have some trajectory of moon. I name it, I track as a knot. In this cases, the moon is very big. And of course, we have questions why it is nice. I don't know why. And we can, and now if we are here, it is very, very simple. Yes, one. And now I do so. It is moon parent. And I say that it is not, and it is clear. The law is, as in another case, but it is more not than in another case. And we can change the first, this moon parent, define vertex, number of vertex, and this define order of moving by this vertex. Oh, one moment, I do not show, I have some mistake. So we have that vertex and second moving from this vertex is so. In that case, it is plain picture, but we can transform in 3D, working with inversion about spheres without problems. And some I read that when Picasso, Salvador Dali was in French Academy, he said that he bring some food with some meat, some piece of meat for them, and then they can do a good food from this meat. And I feel himself in the same position. I do some curves, some images, and I think that analytics can do some very interesting mathematics. Food from this meat. We can, and we can go. It I show not hierarchy 2. This is a simple not hierarchy 3, hierarchy 3. And I look on this. In that case, it is not so clear what mean these parameters. But it is not so clear. We can solve. Not sometimes it is not clear in this from picture. But very interesting play changing these parameters when he have hierarchy 3. I try work with hierarchy 4, but it don't. Hierarchy 4 I don't see something very new, and hierarchy 3 is very interesting. It is not only toric, not hierarchy 3. Very many examples, and you can download this program. It is in common using, free from non-commercial using, non-commercial using, free for this. One moment, Simon. It is, I show, if you are here, I show some moment my questions was. There are online resources of aesthetic geometry, artistic YouTube, some jokes on YouTube, some lessons on YouTube, program from Android, and program for Windows, vertical look. Here I work with Windows program. Android is good for train, and for work I use Windows, website, lecture by Russian, and about me. And this is publication about this item, one book and some article in magazines. And the last article was in magazines in Kiev 2 years ago. And this article is interesting because it was here is about video art, about laws video art. Here I said exactly, and here I said only some moments, but in article it is some. I hope good pictures and good text, but all of this is in Russian. Maybe it isn't. What to say?
Yeah. Okay. This even published in Kiev. I see the 8th one. Is it in Ukrainian or it's still in Russian?
It was bilingual edition, Ukrainian and Russian, and by this reason, this article is on 2 languages, Ukrainian and Russian. And Russia variant was in internet, and Ukraine variant was in paper. And maybe not so, I don't remember, but I have in my hands, I have this magazine. Boris Tuchinsky from Kiev asked me to write for this journal.
I see. Okay, let me see. We are losing people because everyone has some arrangements. In the US, this is the middle of a working day. So so we may want to stop here. There is going to be a recording, which I'm going to send to everyone, of course. Yes. And maybe I stop.
One moment, if you will send, maybe you send my presentation file also.
Okay, yes, absolutely. This is yeah. That's very good. I always prefer to send both. Yes.
I sent to you.
And I then forward it to everyone. Yes.
Okay.
Sure. That can be done. And maybe I stop recording now, then not to have it too long. But first of all, again, many thanks for the talk. And I understand that it was not easy for you to present the lecture in English. Of course, requires some training, and especially taking into account very difficult times. I understand that.
And thank you for these possibilities. I try, and well, when I start, I think that is good, better if I not. It is very complex. I cannot say this. After this, we speak in Russian. Okay, thank you.
Okay, thanks so much. And then I turn off the recording so it wouldn't be too long. How do I do that? Okay, maybe I can do it here. Okay.